Hi everyone, in this video I will show you how to create your own shader graphs for terrain specifically. So obviously you can use them for other mesh basic ones, but they will handle all the useful terrain abilities, for example holes and texture painting. So as you can see there, I created a tiny terrain 100 by 100 and it still has the default terrain lead material that comes with it when you create it. So I just created a few shapes so that you can see. So with this terrain lead material, you can actually paint holes in there. For example, it could be the entrance of a cave or a dungeon, as you'd like. So I will let this hole there, and another useful thing is to paint textures. For example, I can put some grass there and some snow there. So as you can see, if I zoom in, I actually have some grass, some snow, and it fades onto the default texture. So okay, now what happens if instead of having this terrain lead material, we put our own shader material, based on Shadergraph. So I created a very simple one that I'm just going to drag and drop there. And as you can see, everything disappears from the holes to the texture paintings. Obviously, this is not what we want. So as you can see, the material is pretty simple. That's just plain colors with fake shadows scrolling on it. But that can be useful, and you may want to use that as a terrain material. So I will show you how to have everything. So basically, holes painting, texture painting, and your own shader. This is the shader graph I used for my custom material. It's pretty simple, as you can see, and I just use the albedo property of the output node. So to handle holes, first, we will need to set some transparency somehow. To do that, we'll use the alpha clip threshold. So the trick there is to create a new texture 2D. Well, let's call it holes, but call it however you'd like. And the key there is to put the right reference. The right reference is terrain holes texture with an underscore in the front and in camel case. It doesn't need to be exposed. Actually, the user cannot set it. It will be overridden by Unity when you paint on the terrain. So let's just uncheck this. So let's see how this texture look first. So we're just going to sample it. Let's go. So on the albedo first to see what happens there. So if you remember, I made a hole already, and it should appear. There you go. Here it is. So the red is actually a bug. I cannot explain it, but what matters there is white there and black there. So it gives you how the holes are actually stored by Unity. And to show you that if I paint another hole there, it will appear instantly. So pretty cool, right? So instead of displaying on the albedo, which is obviously what we want, we'll set the alpha clip threshold according to it instead. So in order for the holes to be visible, we need to put the alpha value down just a little bit. So let's just put something lower, whatever it is. There you go. And it has to be higher than 0.5 as well. So just 0.9 should do the job. So let's check it out. There you go. There you go. We have our holes and cloud scrolling on it. So that's the trick. Basically, I think this is what we could expect from this. So it looks okay, not buggy at all. And we can draw other holes or refill some without any problem. So okay, now what we want is to do some texture painting. As you can see, I still have my grass and my snow supposedly there, but they don't appear. Well, actually that's kind of the same thing, and I will show you how to do it. Let's just group this and call it holes handling. so that we can just put it somewhere and we won't touch this anymore. So now what we want to do is find out how Unity stores the texture paintings that the user actually made. So we'll just move out the albedo for a bit because we want to somehow debug and see some other weird texture that Unity sets by itself. So I will just give you the trick. So there's another texture called control. So called control, and well, the name doesn't matter as usual, but it has to be called control. Same as whole, it doesn't need to be exposed. Let's see how this texture looks. I'm just going to set the albedo as usual to debug. Let's just save and see what we get there. There you go. As you can see, everything is red except where we painted. So you have green there where we had grass, and you have blue there where we had snow. So how does it work? You can have up to 4, where are they? Paint texture. You can have up to 4 layers there, and each layer is controlled. So the intensity of each layer is controlled by a channel in the color of this texture. And as you can see, it's not always blue or always green or always red. You have some interpolation between them, and you have to use this to make a smooth transition between them. So basically, we'll just keep this somewhere. So I'm just gonna group it and call this control and put it somewhere. So now to actually paint the right texture, the right layer on the terrain through the shader, you need to access all these data there. So you have the diffuse map, the normal map, potentially the mask map as well. Everything is stored by Unity again. So basically, same deal there. You still have some magic texture 2D to set up there. So let's call it, I don't know, like layer 1 albedo. And it will be called splat 1. Same deal. You don't have to expose it. And this texture 2D, so let's see how it looks to make sure that it works. So the whole terrain will be covered by this color. So let's save and check it out. There you go. You have some grass there, perfectly scaled as you can see, but we'll deal with it later. So as you can see, I could access this diffuse map there from the reference splat 1. So basically, as you can imagine, you have to create this for every layer except the first one. The first one will act like an eraser actually if you want to come back to your well, original shader, should I say, like the albedo we had before. As you can see, I already created my 2 others texture 2D that contains the diffuse map of every layer. So I don't have any 4th layer there, but even if I do, it will be stored in the splat 3 reference by Unity itself. So now what we want, instead of just painting a layer on the whole terrain, is making some interpolation between every layer according to which layer we should have. So the layer 1 is controlled by the green color. This should be set when the green equals 1. So we're just making a lerp there. So the green color controls how much of the B we're going to use, and obviously the B should be the grass there. What is the A then? The A is the the other layers. So basically the one we have before is our initial color. There you go. So we can already check what we have there so that you understand. We should see our default shader, the one we had, and the grass where it's supposed to have grass. And it should be smooth transition between the two of them. So let's see if I'm right. There you go. Exactly what we wanted. And the transition is smooth. It means that if you take a brush that is, well, that has a low opacity, you will be able to paint in a low opacity. That is, well, how the default terrain material works. So pretty cool. And as I told you, this first layer will act as an eraser. As you can see, it comes back to the the shader we created first. Pretty cool, right? So let's just make the same thing for all the other layers. I just did a sequential linear interpolation there. So as you can see, we've displayed this node as the albedo previously, but instead of displaying it, we're just putting it at the input of the next interpolation. Let's save and see what we've got there. We should have the snow and the grass. There you go. Does work. And still this one acting as an eraser. Pretty cool, right? Okay, but we're not done yet. We still have the normal map, the mask map, and also the metallic and the smoothness there. So let's group this and call it texture painting. Yeah, okay. The normal map and the mask map will be kind of the same deal than the albedo. So we're just going to create another texture 2D, and let's call it layer 1 normal. And the texture needs to be normal 1, just as you could expect. As usual, we're going to uncheck exposed. And so let's drag and drop this there first. Normal map is controlled by the green channel there, so we're just going to make a lerp, and this input will be the B. Oh no, sorry, the T, and this one sampled will be the B. So there you go. We have the normal map. We need more rigor there because this is not a right normal map, 0. So we're just going to make a normal from height, and it will be 0 as a height. So no normal map. And let's plug it into normal there. And this should be enough to take into account the normal map that we painted. So let's save and check it out. So it's pretty hard to see though. So let's, oopsie. But it looks like it actually works. After debugging for a while, it looks like the normal map actually works, but there's a bug doing that. The smoothness doesn't actually affect where we paint it, but that's not a problem. Actually, we have a slider for smoothness and metallic there, and we're going to override the metallic value with this one where it's painted. So basically always the same deal. You just need to know the references, the name of the references that Unity sets. You need to check the default terrain shader. And actually, if I get to it, I can see all that we've done so far. So we've put them already. We still need to put the masks, but I just want to put metallic and smoothness in priority. So as you can see, it's just called smoothness 0, smoothness 1, and it's just a slider between 0 and 1. So let's get back to the shader graph and create a new vector 1. Smoothness 1, and it's a slider between 0 and 1. So let's check first if it's connected. So we just set this, we save, and back to our scene, we're going to move the slider of the first layer, meaning the grass. And there you go. Well, I'm just grouping those because we don't need them anymore. Basically, we just delete this link and we have the smoothness. We lerp this with a constant value that we are going to let to 0 for now, and it's controlled by the gray channel, so the green. So if the green is high, we'll take the smoothness 1 there. So I'm just going to create the others. So there it is. I just created the sequential interpolation, still according to the control group that we made here. So we should have the control over the smoothness in the painted areas. So let's just group it. There you go. So instead of putting this in the smoothness first, I've put it on the albedo. I will let the normal map just to check it's still here, and the alpha threshold, so the holes and laying as well. So we should see white where it's smooth and black otherwise. And the default smoothness will be 0 so that it's easier to see. So let's get back to the scene. So this is what we've got. So the first thing we can see is the normal map is now fully working. So let's take this layer and increase the smoothness. There you go. You can see the smoothness becomes white where it's smooth. And well, same for the other layer there. Yeah, beautiful. So now that it's confirmed, we can put back the albedo there on the smoothness, because this is what it's meant to be. And let's put back the albedo we had. There you go. So let's save and see what happens. You can control something, so it means that it's possible. So now we need to do the same for metallic. Back to our shader graph, we're just going to create a new vector 1. Let's call it, sorry, metallic 1. And we put just the right reference there. As usual, we don't need to expose it, so we can check this. And this should be a slider between 0 and 1. Okay, beautiful. So let's just check that we can control it. So this will be the metallic of the whole terrain. We just want to make sure that we have control over it. So I take the layer 1 and I take this slider. Okay, as you can see, it works pretty well. It controls the metallic over the whole terrain, including, oh, that's interesting, including on these areas there. Guess what? Another time, the exact same thing. So metallic 1 will be part of the lerp. It will be B. And this lerp is controlled by the green channel of control. Here we are. I just added the other metallic references, and I made still the same lerp that I'm going to call metallic painting. And I directly connected this to the metallic, so I'm just going to save and see what happens. Okay, so here we are. The metallic is now controlled, so we're done yet for the metallic and the smoothness, but as you can see, there is a third thing there, which is called mask map. As you can see in the Unity documentation website, the mask map is composed of 4 channels, and the red channel is for metallic, the green is for occlusion, the blue is for detail mask, and the alpha is for smoothness. So we've already dealt with smoothness and metallic, but in case we have a mask map, it's not clear what exactly you should do. I personally want to blend them. Still the same thing, create a new texture 2D that we'll call layer 1 mask. And I will do this for every layer. So there you go. And as usual, I'm going to make a lerp between all of them. Now we have our mask painting group. On the output of this one, we're just going to split, making a lerp with a 0.5, and we take the metallic there and we plug it into metallic. So let's just save and see what we have. And try to play around with the sliders. If we increase, it increases the metallic. For the smoothness, that's pretty much the same deal. We just take the alpha component. Okay. So let's just lerp it. Yeah, that's a new verb. With the smoothness, I guess it's here. Yeah, there you go. With a tolerance of 0.5. What you could do actually is to put a slider there that is exposed, that the user can choose which smoothness and metallic to use, the one from the detail map, from the mask map, or from the slider there, because they both contain the information. So now we've made the smoothness right. Yeah, looks right, so we're just going to save it to check. As I said, the grass is not very smooth within its mask map, so it shouldn't be smooth either. But you can still make it smooth somehow. And yeah, it's more plastic looking because metallic is 0 and this is not more metallic. We still need to put the occlusion. So where is it? Occlusion there. So now what we want is to obviously tile this grass. I mean, it looks beautiful, but come on, this is not how grass should look. So yet we haven't used a few parameters that we can see there. For example, the normal scale, we didn't get it, and the tiling settings either. So to do that, it's a bit more touchy. Actually, if you go back into the terrain lead shader, you won't see any of this there. So we use all of them, but actually you have to dig a bit deeper to find out where the tiling and normal scale settings are, and it's actually in the file terrain input.hlsl. So as you can see there, I have all the normal scales for every layer. Well, I still have my metallic smoothness. So I have a lot of things there. I guess all of them are useful, but the only thing I'm going to use are those. Splat 0, splat 1, splat 2, splat 3, underscore st. Well, I don't know exactly what it means, but I tried, and this is actually what we need to set up entirely the tiling and offset. So let me show you. Let's get back to Unity and create a new vector 4 that will contain both the offset and the scale of X and Y. So the tiling basically. So it doesn't need any default value because Unity will override it anyway, and let's just hide it. As you can see, we have a lot of properties there, but only the one with the red dot are used. Are shown into the material settings, so it's pretty fine. basically only yours, only the one that are specific to your shader. So with this, we can create a, let's zoom a bit. So we can create two vectors. So I'm just going to split it, and the two first values will go into a vector 2. So I think these are going to be, these two values are going to be the offset. Maybe that's the opposite, I don't know. And those two will be the tiling, but we'll know pretty soon. And we just create a node tiling and offset. And so, well, basically you have to choose now. I guess it will be the offset and the tiling. Just to try, I'm going to link this. It's not expanded yet, so I'm going to use the albedo of the layer 1, and I'm going to use what we just created as the input UV. By this way, we should control the albedo only. As you can see, I can change the size of it all, that I actually need to take 1 on these values. So I'm just make a divide node and putting 1 as a value there. So this way, the higher the value will be, the smaller. There you go. Well, it looks like it works as intended. Now we need to apply this process to any of the layers and any of the texture 2D that I have per layer. So the normal map, the mask map. So it will take a while. Here I am. I just created all the layer 1, 2, 3 ST, and I made small some groups to get the tiling and offset for each of them. Then I connected these to any sample texture 2D, so that both the normal map and the mask map, as well as the diffuse map, will get affected by the tiling and offset, just as it should be. So let me show you. Should work. Okay, there you go. So as you can see, my grass appears pretty small now. I'm going to increase the smoothness. Well, it matches the diffuse map perfectly. So yeah, the normal map moved as well. Now there's still a few things that we can do. It won't be that smooth if I put 1 there, and the reason for that is I have no mask map. So I can't reach the maximum value of smoothness. It will be way smoother than that. To get around this issue, I found out in the code that I actually have access to some properties. Layer has mask 0, 1, 2, and 3. I guess this will be set to 1 if the user provided a mask map, and 0 otherwise. So I thought about another way of doing it. So I'm still there with just the occlusion plugged in, and I just want to change these values. So let me explain. The mask mixing will actually be just an addition. So for the metallic, I will just add the 2 values and connect this so far away on the metallic, and it takes 3 hours. Okay, and for the smoothness, that is exactly the same thing. It will make a value between 0 and 2. And the thing is, if we have a mask, we don't want the slider value to be taken, but for every layer. So instead of having these inputs, which are directly the slider input, we will multiply these values by 1 minus has mask of the same layer. So basically it would be 0 if we have a mask there. So in all cases, if we do have a mask, the output there will be 0, but the value there will be between 0 and 1. So the result will be 0 and 1. And if we don't have any mask, then this value there, as you can see in the lerp, will be 0, because these two values are 0. And thus, the resulting add will be between 0 and 1 as well. So I did this for any slider value of any layer. So let's save and let's see what we've got. And there you go. I don't have a mask and the sliders are actually taken in account. So the last parameter we're going to set in this tutorial is the normal scale per layer. So it's a really important one, so let's get to it. Those are actually vector 1. So we want to control the strength of our normal out there. So for this, there is a special node called normal strength, as you can see there. So we just takes the normal map as an input, a strength, exactly what we have, and out. So it's as simple as that. Okay, so Shirley does something. To help me debug this problem, I created a new terrain with the default terrain as a reference. I just painted a small portion of grass and I increased the normal scale. As you can see, it doesn't act the same. So I'm doing something, but I'm not doing the right thing. Another thing I realized is I was wrong about the size. Like the bigger it is, the bigger it will appear. I was mistaken with the noise scale. After a bit of struggling, normal strength is actually the right node, but I need to be in normal type in the sample texture 2D. And I guess that was the weird behavior we had on the normal map before, was due to that. So here they are, normal strength applied to every layer. So I'm just going to save it and to test it out. Once you handle the terrain properties correctly, you can think about a more efficient way of doing terrains. So instead of just having clouds crawling over, I created a pretty cool tool to make your terrains. For example, if I want to raise the terrain, it will instantly adapt according to what I'm doing. So if it's steep enough, you will have rocks. If it's high enough, you have snow, and on the other side you can have sand if it's low, and even blue like water if it's really low. Terrains are not always so fun to do, so I guess with this shader it will be super cool. And obviously that's the point of the video, it's fully functional with holes, for example, as well as texture painting. So there you go. It's pretty nice. You can do some nice things, and it's so much faster than if you were using drawing all of this by hand. I hope you enjoyed this video and that it has been useful for you. I struggled quite a bit to get into the source code and understand how Unity terrains work. So if you like the video, please subscribe and leave a like. See you next time. Cheers.